This conference will now be recorded.
Ankita, what is the limitation of 1.x? We have a two version 1.x, 2.x, even 3.x. But stable is 2.x. So anyone answer me, what is the limitation of 1.x? Yes, please. Deepak, Bindu, Arun, Ankita, Richa, anyone? All right. Limitation of 1.x. Hadoop 1.x, Ankita. Am I audible? Hadoop 1.x limitation.
It's something like in 1.x the block size is very less. It's a 64, and in 2.x is it's I guess around 128.
2.x what?
It's a 128.
What is 128?
The block size actually.
Okay, apart from this,
It was only suitable for batch processing.
which one?
1.x.
Is it? No, it's not like that. 1.x, we are doing the batch processing. Okay, this is the architecture, guys. This is the 1.x. This is the client. This is a name node. There's a secondary name. There's a job tracker. So one challenge. Let's talk about SDFS part. Then we'll move into the data processing part. Okay. So in 1.x, we have in SDFS only one name node. Okay. So this session is more into admin today, and that will help you to control your cluster. You will talk more about cluster optimization, troubleshooting, and in Spark, if you're deploying you're on top of Yarn, you're deploying the Spark, how you can control all this optimization of Spark as well. Okay. So guys, this is what we have only one name node. Right? We have only one name node. So Arun, if this name node get down, what you will do? If it's down, yep, only one name node. Only one name node is possible to configure. I cannot understand when what you're doing. So there's a single point of failure, guys. It's very simple. If name node down, its entire cluster will stop working because all node coordinate with the name node. Data node, job tracker, anywhere, secondary name node, all dependents on the name node as well. So if you have a one name node, entire cluster will stop working. So in a 1.x, name node is what called single point of failure, and that is what in 2.x they come with a two name node, one active name node and second is what? Passive name node. So if active get down, the passive will become active. Clear?
Yep.
Okay.
Yep.
So you can write down, guys, please. So in property wise, name node 1, Hadoop 2.x we have many. High availability, not present. High available. Okay. High HA means what? High availability means there's a backup of name node. That is what HA features. In 1.x, we have map reduce framework in which we have the component job tracker and task tracker, right? That is what you have MR framework here. Guys, this is very, very important, and theoretically, we are discussing today more theoretical and then practical. and you have to ask me very logical question as well. So this is the MapReduce framework. We have almost done with Hadoop. This is the final topic for the Hadoop. After this, we'll start the Spark. So this is what MapReduce framework. MapReduce what? Master slave, job tracker, and task tracker. So in 2.x, what they did, they replaced the MapReduce from Yarn. We will talk about the limitation of MapReduce as well. Yarn, yet another resource navigator. We'll discuss that as well. What is Yarn? MapReduce versus Yarn also will discuss. For today's session, we'll discuss about SGFS 1.x and 2.x. All right. So in 1. You see that in Yarn, what we have? Resource manager, node manager, and application master. Node manager, resource manager, application master. Okay. Let me just trying. So right on, guys, as Hadoop, so I mentioned again, today we'll discuss about SGFS. In 1.x, what is SGFS, and in 2.x, what is SGFS and how it works. So you can write as Hadoop 2.0 SGFS Federation. Okay. Hadoop 2.0 SGFS Federation. So see, this is the one name node, and two is a data node. One is a name node, and two is what? Data node. All right. Okay. In 2.x, what we have? Multiple name node, and only we have a two name node, guys. Okay. And we have multiple data nodes. So guys, day one SGFS architecture. Hope you guys remember. We talk about many things, how name node maintains the metadata, how name node maintains replication factor, how data node communicate with the name node. There's all the concept we'll recall today. It need required. So in 2.x, how it is all happening. Okay. So I hope we can expect you the answer of SGFS architecture what we have discussed. So in this, we have one name node, multiple data node. We have multiple name node and multiple data node as well. Okay. So the first question, what is the advantage of putting two name node, guys? Can you answer me? If we have a two name node, what all the advantage we can have it? Richa, you can see your offline. Yes, Ankita, if we have a two name node, what all the advantage we can have? The first advantage, we have a backup, right? Right, guys, we have a backup. Next, the both name node maintains the metadata together. Now ask me, what is the second point? The second advantage, it maintains both name node maintains the metadata. Both maintains the metadata. So you might be confused what is the advantage of two name node maintaining the metadata, right? So see here. Okay, so let's say you have one name node. Okay, let's say your RAM size is 2 GB RAM, right? 2 GB RAM. So if you have a 2 GB RAM, name node put the metadata where, guys? In the RAM. So that is why name node is what called memory hunger. If you have a 2 GB RAM, if you have a 2 GB RAM, so a one name node can maximum put the metadata 2 GB RAM. Let's say 2 GB RAM filled. What you will do, Arun? Next, you will increase the RAM size, right? Or paging concept to maintain the memory size, or you will increase the RAM, right? This is the one way. You add the 2 GB, you add the 4 GB, you add the 8 GB, and you add just 16 GB, but there must be some limitation. Beyond that, you cannot do that, right? So this scalability is what called vertical scalability. What is called, guys, technically? Vertical scalability. 2 to 4, 4 to 8, 16. So this is the vertical scalability, and vertical scalability having the limitation. So not more than 16 GB you can increase the RAM. Operating system will not support, right, guys? Okay, the machine will not support. Clear? So what will happen here? If this vertical is coming increasing, so you have this, you're not beyond, so 16 GB RAM, then so this is called vertical scalability. What we have the advantage in the data node, why we are putting the multiple data node? Let's say your data node maximum support the 10 GB of data hard disk, right? You can add it the one more data node. So now we are not increasing the RAM and increasing the storage in the same machine. We are adding the new node. We keep adding the new node, one machine, two machine, three machine, and we keep going on. So in 1.x we can have it 4,000 maximum node, we can add it 4,000 maximum node we can add it, right? So this is the limitation, guys, right? And technically this is what called horizontal scalability. You got it? So adding a new node in the cluster in the setup, it's called horizontal scalability. Hope you guys are clear. Now in 2.x say that, hey, even for the name node you can perform horizontal scalability. Is that how possible? For the name node, how can I do this? So it said that in 2.x we are coming with the two name node. I said yes, because I want backup for the name node. Once name node down, I can use that passive name node as active. So it said that it's okay, but why don't you use one more advantage for this? Why don't you use the advantage for this? It's okay if you have a active and passive, I understand, but one more advantage you can have it. Active backup you have, that is fine, but what is the one more advantage you have is you can maintain the metadata in both the name node. So what is the challenge you are facing here? You have vertical scalability and the limited storage. You do one thing, maintain the metadata in the both machine. So this will help you in terms of horizontal scalability. Which one is better, guys? Horizontal or vertical? Ankita? Which scalability is more powerful? Vertical or horizontal? I hope you guys are clear, Bindu. Deepak? Yes. Can I get a quick response? So horizontal scalability is more because it has the more potential to increase the scalability. So this is the another advantage, guys, to increase the RAM in the two name node and giving you the output for you. Hope you're clear.
Sir,
Now this is
sir, I
what,
have a question.
yeah, please.
Yep. So in 2.x, as you mentioned, like we have multiple name nodes for the high availability and backups. So suppose my one name node having a details like metadata for the data node for 10 data nodes. So is it like if I having a multiple name nodes, so that that metadata will be copied to across all the name nodes?
That will come on to, just allow me some time. How name node maintains the metadata, we will talk about, and how this both the name node maintaining the metadata will discuss. Okay, we just understand if there is a two name node, we have a two advantage. One is a backup and maintains the metadata. Okay, so the first question, is it Aniket?
It's Deepak.
Deepak. Okay, caller 01, who is this? Caller 0. So Deepak, okay, how it worked, let me help you. So guys, the good question, then how name node maintains the metadata? The first question, the how this two name node maintains metadata together. So guys, how data node communicate to the name node, guys? How name node maintains the metadata? Hope you guys remember. A data node send the request. Remember the block report. Block report. Data node sent to the name node. This is called block report, and that is the 10th heartbeat. Right, 10th heartbeat. Hope you guys remember. And through which name node maintains the metadata. So based on the notification, name node the metadata. Okay. I know that there's only one name node. Let's say guys, you all are data node. You have a 6. So you all are data node. I'm a name node. So how you know very well whom you have to ask the question, right? So you're asking me question. But let's say in this session we have a two trainer whom you will ask the question. You get increase that because at a time one trainer can answer your queries, right? So bandwidth is student has to wait for this the queue system. But now I give you the two trainer. But how you know that, Deepak, which trainer you have to contact? Which trainer, Arun, you have to discuss? I have given the potential, I have given the bandwidth, but how you will know? So the same question, data node is being asked. Hey, we have a a name node. All right, you can both name node will maintain the metadata, but how data node will know which name node I have to connect? Either data node name node 1 or name node 2, because both are maintaining the metadata. So it's a that you don't need to bother about that. The same way I will ask, you don't need to bother about which trainer you have to coordinate. I'm giving you one chat window or a mediator. Chat window or mail. You just drop the mail, what all your query you have. The trainer will check that and will work and come back to you. The solution is done. The solution, you got it. So you don't need to bother about how many trainers we have. All right. Okay. So here, what it will do, it will the same way that is called block pulls. See here. Here the data node directly communicate with the name node because only one name node we have. We have multiple name nodes. So I will say you send your report, your metadata report to this block pulls, and through this block pulls, name node will maintain this. Hope it's fine.
Yep.
Deepak, hope it's clear.
Yes. Yeah. Yes.
Yeah.
Clear.
All right. So this is how this thing will go.
Sir, but is it like if you have multiple name nodes, so uh, I believe like it doesn't have some the concept like the primary name node, the secondary name node, like
So we have
the
one more.
first.
We have. I'm coming one by one. Just allow me some time. Let me complete all this thing. So your primary name node, Deepak, it is called active name node, and the secondary is called passive name. Okay. So what will happen? Okay. So data node job is over. Data node now understand it's whether it is a one name node or 10 name node. That's not my problem. I'm giving this block pull. I will send the metadata to them. That's it. Okay. Fine. Now the second question: how client will interact with the name node? Because name node at a time only one name node can be active. One name node active and one is a passive. All right. One is active and second is what? Passive. So how client, because user send the request to guys what? Let me just go through this. You see here, user send the request to, this is the user. When you write on your cluster, user send the request to the client. Client send the request to the name node, and name node will decide on which data node data should be stored of this user, right? So here only one name node we have. The client will directly interact with this. But what in case if we have two name node, then how the client will coordinate which name node is active and one is passive? Question. So first we'll learn about interact the contacts. How data node communicate with a name node is clear now. How client will interact with a active name node, because in a cluster only one node will be active. So client, how client will know that who is the active one? So user send me the request which name node I should interact, means which one is active. So guys, there's a what called fencing. Let me show you. Right on. Fell over. What is guys? Fell over. So this is the process running on name node. So what it will do, which name node is active? What guys? Which name node is active? What it will do? One program will be running. Let's say this name node is what? Active node. So one program running, that is called fencing. So its job is what? This name node will send a signal to the client. And from which node the client will get the signal? Means client will come to know that this node is what? Active. This is how the communication had happened between the active name node and the client. Clear guys? Active name node and the client. So this process is what called fencing. Now sometimes what happen? Now what if else condition will come, because this is all based on signals. This is all based on signals, right? So what I will say, active name node is this, client is this, failover is running on. Now if this name node, down, now the passive will become active, right? Passive will become active. So now this fencing program will start running onto this machine, and immediately it will start sending the request to the client. The client will start interacting with this passive machine, means not become active. So it's a complete process guys about fencing, on which machine this program will be running. Sorry, not fencing, failover. On this machine this program will be running, that will be the active name node, and the name node will interact with that machine and give you that solution. Okay, that's fine. Now let's consider one case. This is the name node. Name node dependency is what? Name node has to send a signal to the client, and the client then only interact with that name node. Now let's say partial failure had happened. Now this name node send a request to the client. This name node send the request to this client, but client did not receive the signal. This technically what called partial failure. It happened with you as well. You send the message but receiver not receive the message. So technically it is what called partial failure. Now what the problem will happen? So client will come to know that I'm not getting a signal. There is some time frame, and it will declare zookeeper, hey, this name node is not responding, I guess it's dead. So zookeeper will make this name node as a passive to active, and now this name node will start sending the signal to the client, and client will start interacting with this passive name node, which become active. But what was the situation guys? This name node was not dead. Now after some time the communication stable, and now client start getting a signal from two name node, because this name node was not active, because it was network failure, it was dead. So what will happen guys in that case? It's a completely chaos. At a time only one active name node will run. It's as simple as it is. And if this case it happen, then you have to kill the name node. Which name node? Which was declared dead. Means this name node which was declared dead, now if become active because of some reason, partial failure, now you have to kill the name node. So there's a three how to kill the name node. So we'll discuss killing the name node. Failover, you understand? Okay, fencing. Fencing is the part what? Revoked. So see here. How? Okay. So all right. So see here. Interesting part. So what both the name node do? This data node sending the request, maintain the metadata to block pools, and this block pools both name nodes maintain the metadata, and there's a one common directory through which it access the metadata. Okay, so you can say edit log. We have discussed about guys fs image edit logs, right? You can say this is what your edit logs with all the transitions are stored. Okay, this is a common directory. Now this name node is what? Active. So which name node is active? Only can access this edit logs and serve the request to the client. Read, write, data processing, whatever you have. You got it? All right. So now in this case, what will happen? This name node stop working. So now it become active. So now active will get access of this edit log. All right. To serve the request of the client. Okay. Now what problem had happened? Because of this partial failure, this dead node become live and start giving you the service. So clients say, hey, kill this name node, kill this name node. So how to kill this name node? You just revoke this access of edit log. Don't allow this name node to access this edit log. If it not access the metadata, it will not serve the request. So this technically called what? Fencing. Revoke edit log, remove the access of the standard edit logs. This is the one way. All right, guys. All right, this is the one way to move this fencing. What is next? Stone it. In the worst condition, if this name node is not getting dead, if still this node is active, the third and final option, short the other node in the head. Short the other node in the head. Whenever your laptop misbehave, if it is not following what the command you're giving, you give the power of the signal, right? Power supply stop, you restart the machine and you try how it is working. The same thing had happened here. So you give the higher power supply which goes down by sending the higher power signal, and once the power signal is stopped, it automatically will stop working. So this is the three different approach to kill the name node. Okay, yes, now you can ask a question, guys. Yes, Deepak, Bindu, Arun, Ankita, Richa. Any question? So how data node communicate to each other, how name node interact with the client, and how the metadata is maintained, and if in case this situation occur, how to kill the name node. Please let me know if any questions. You can write in the chat.
No, sir.
Okay, Deepak, you had some question about how name node maintains the metadata. Is that clear?
Yes, sir. Actually, I got disconnected on the same topic. Uh,
Oh,
but anyways,
okay.
means I understand your last explanation actually, which you have given. So,
Okay, It's very simple how both, okay, I repeat once again, how both name node maintains the metadata. They both will take the metadata from here and they will create a one common directory through which they can access the metadata, because, and that is what edit log, because at a time only one name node can be active.
Okay.
So this name node is active, it will access this edit log directly. Both active and passive both maintain the metadata, but only who can access this edit log common directory? Those name node, that name node which is active name node. That's it. Okay.
Okay.
So if this name node is dead, now this passive will become active. I will give the access to this edit, this box to this node, and now edit log, it will access this. Clear?
Yeah. Yeah.
Okay. Any question, guys? Arun, Bindu? Okay. So this is what about your SJFS federation. There's one link also. If you want to get more details, you can go to this or to Apache and get more details about SJFS federation. So this is how 1.x and 2.x, and in SJFS, how, what are the limitation on Apple and how we maintain this.
So sir,
2.x.
currently people are using 2.x, right? In the production
Yeah,
also,
yeah.
right?
Yes, 2.x we have, of course, and even the 3.x is there, but
Okay.
it's not yet stable. Enterprise level we are using 2.x. So in 3.x we have I guess more than 2 names. Okay. See here. If we talk about the MapReduce is what? Master slave architecture, right? Master is what? Job tracker. And the slave is what? Task tracker. It has multiple limitations. We'll talk about this limitation as well. So in 2.x, they replace this from Yarn. Yet another resource navigator. It is a platform where we can run distributed application. Okay. It is also master slave architecture. Master is what? Resource manager. Slave is what? Node manager. Clear, guys? We'll talk about the more roles and responsibility of Yarn. So just a quick overview. Resource manager, which will allocate the memory, the resource to run any application on the node manager. Monitoring the running application. Application master, which manages the life cycle of the application. So let me come directly onto this. You'll get the more clarity. Yarn. Okay. Yarn versus MapReduce. These are the component we have in Yarn and MapReduce. Now, what is the job of the job tracker? We'll talk about, and how this all the job. There's nothing has been changed. The component and the framework will change. Rest is the work which job tracker do. Who perform this application? We will talk about. So in 1.x, who initialized the job? Job tracker. In 2.x, who initialized the job? Application master. What are the job is running on the multiple task tracker? They keep sending the report to the job tracker and maintain this all the report of the job status. Here we have a timeline server. Do this job. Job tracker job is what? It allocate the resource as well to the application. You're running the job and how much RAM slot processor, right? It's all work done by the job tracker. Here this work is being done by the resource manager. So all these three job, what job tracker do single-handed handle this, it all be done in the three different component in yarn. What task tracker do? Here it is what node manager. We have a slot like job. You give the container slot is what? It's a resource allocation. So if you're running a one job, it's a 2 slot, 3 slot you're giving. Here they are giving the they give the name in terms of slot. Give the 2 slot of this this particular job. Here we use the terminology container. We'll see this in the practical. Okay. Now see that. What is the major difference between the yarn and MapReduce? Scalability. MapReduce maximum you can have 4,000 node and 10,000 tasks you can run at a time. Yarn 10,000 nodes. This number of tasks you can run parallelly. Availability. It's a single point of failure, right? You have a resource manager and application master. We have a backup completely. We have just discussed about high availability. Utilization. The biggest challenge was in the MapReduce. Excuse me. The biggest challenge was in MapReduce. Let's say this is a 2 task tracker and this is the job tracker, right? User send a request, hey, this is the one job, please run my job. So job tracker will assign this job to this task tracker. So whenever you're running the job, what exactly? It run the job in terms of MapReduce, right? So job tracker will assign the resource to this task tracker. Well, just now we discussed how we assign the task tracker. That is called slot. So it given the 3 slot to mapper and 2 slot to the reducer. All right. I'm just taking a one case. Now it say that now remember that at one point mapper and reducer both will start parallelly. Remember this. This is the point. Mapper and reducer both start parallelly. So what will happen here? Reducer, excuse me, just a one. So what happened? Reducer said that, hey, what the slot you have assigned to me, resource you have assigned to me, it's not sufficient. Kindly give me some more resource. So this request will be given to whom? Job tracker. Okay. So job tracker have a limited resource, guys. Remember, let's say a demand for reducer demand for 3 slots and job tracker having only 2 slots. So what it will do? It will not fulfill the requirement of reducer. This is the one limitation, guys. That's the biggest challenge in the MapReduce. Even the MapReduce take too much time. One is because it's a batch processing, read and write data randomly. Sorry, it's a disk processing. You read the data from disk, write the data from the disk. Again, and there's the 2 cycles to complete a one job. This is the one reason why it not support the real time. And the second reason is also why it has the poor performance, because if reducer demand more slots, if job tracker having not that much slots, then it will say, hey, just wait, just wait. Once mapper will release this slot, will assign you this slot, and now reducer stop, or not stop completely, the process is getting delayed. So once this mapper complete 100%, then it releases this slot and it will give this reducer because of insufficient number of slots. Okay, so Jan say, hey, why you're waiting, why you're wasting the resource as well on the job? We are the distributed application, we are known for the high fast scalability. So Jan say what? Utilization. So Jan say what? I'm giving you what? Node manager, which manage all the pull resources. So anytime if any resource need more resources, directly directly contact to this manage pull, means that's managed by the node manager. So it will give you the complete resource. You don't need to dependency on other resource or slot. Okay, so which eligible the task to run the application using this resource. So Yarn technically it is fine grained. You can see why, what are the problem you can sort out using the Yarn. Okay, so this is what utilization. Multi-tenancy. You can run different version of MapReduce program as well. Again, what is a MapReduce version? So see here, we have run the MapReduce program, right guys? So okay, you can run the MapReduce program on Eclipse as well. You can run the MapReduce program in Eclipse, guys. Yes, that is possible on local machine. You can run the MapReduce program on 1.x as well on Eclipse, or you can say IDE. Take care. You can run it on 1.x as well, right? Means Hadoop 1.x on a cluster. You can run the MapReduce in 2.x as well. Okay, so see the name wise, this is called local. If you're running the MapReduce on local, on IDE, this is called local. If you're running the local mode, if you're running the 1.x on 1.x, running the MapReduce on 1.x, so it is called classic MapReduce. Classic MapReduce. If you're running on classic MapReduce mode, if you're running in 2.x, that is called yarn mode. Understand, guys? Now just understand. These are 3 different approach. There are 3 different way you can run the MapReduce: the mode, local mode, classic mode, and yarn mode. Now you switch 1.x to 2.x. Your cluster set up from 1.x, 2.x, right? In this 1.x, you're running the job in the classic mode. Now in 2.x, you have to run in the yarn mode, right? For any reason, if you have to run your MapReduce program in classic MapReduce, right? I'll do that because you have switched to 1.x to 2.x. So 2.x say, hey, no need to worry, I support all this. I support all this mode. You just, there's a one parameter, there's a configuration. You set the mode, which mode you want to run the MapReduce. Yarn by default is this, classic or local. All right. Local, it will just debug the MapReduce program. Classic, it will run the job by the job tracker, task tracker. If you set it in yarn, then it will be run, job will be done by your resource manager and node manager. So this is the feature. we are having so that is what called multi-tenancy. Yarn having this, so there's no dependency, there's no problem even you have shift 1.x to 2.x. It support the multi-tenancy as well. So run different version of map reduce. Okay. Any question, guys?
So
Let me just
so
set up as yeah, please go ahead.
yep. So as I understand,
Yes, yes, please go
like for the 1.x and 2.x, the map reduce, both the versions having the map reduce concept same, and just the resource
ahead.
allocation is different, right?
Component get
So
component, component get changed. Wait. Component get changed. In 1.x, who's running the job? Job tracker and task tracker.
tracker,
In
correct.
2.x, who's running the job? Resource manager, node manager. That is maintain. So maintenance team has been changed. You got it?
Yep, yep.
Okay. Yep. Yeah, please ask me if you have any question. Yep. Any question, guys? Arun? Arun, Ankita, Richa. Arun is not there. Yes, Ankita. Okay. All right. Thank you. So let me open the setup and I'll show you this practical what we have. Take time. If you have the setup, you guys, you can start this. Okay, so it started. Take some time. Will take some time. Just allow me a minute. So we'll start this. Uh, Bindu, you're saying some docs are not available. The file. Yes, Bindu. Yeah, Bindu, can you hear me? Ankita limitation could not hear you. So use book project. No, there's available. I'm not sure how you're checking on. Guys, did you get the project of last part? Yes. Deepak. Yeah. Okay. Let me just open the share folder. My project. This is a book project, right? This is the file. I'm not sure why you're facing this issue again every day. Is it fine, Bindu? Can you check this? Can you check it from your end? Is it there? It's there, guys. Okay. All right. See here. So, guys, this is the Cloudera manager. I will open this here and I'll show you all the stuff what we have discussed till now. It will take time. So, username and product will remain same. Username password will remain the same. Cloudera. It will take some time to start. Okay. Meanwhile, I'll start it. So see here, anatomy. We'll talk about anatomy. What else advantage you have of Yarn, guys? Uber job, Uberization. If someone asks you what is the Uberization in Yarn, so I tell you. So let's say, Bindu, you stay in BTM. Just understand, you stay in BTM, right? And your office is into what? Whitefield. The guys who are into Bangalore, they can understand this. So it's BTM to Whitefield distance is, let's say, 30 kilometer. Okay, Bindu office, right? So what Bindu do usually? She take the cab and reach to office every day. On Saturday, Bindu got a call. Hey, although it's a leave, Bindu, you have to come to office. There's urgent and some production support and reason you have to visit office. So you'll ask Bindu how to come. So the same cab will come and pick up you. In this cab, actually it is a 20-seater cab. Okay, so 20-seater cab every day, 20 people take it and going to the from BTM and travel to Whitefield. Okay, but for Saturday, this 20 people not there, only Bindu is there, so only one. So what we have 20-seater cab for one user, one passenger. Bindu, you reach to this 30 kilometer and go to office and you work. So guys, do you think so? To carry one person, you need a 20-seater cab, and if it happens frequently, it's a loss, right? You understand this, right? So the same way, if I say you, hey Deepak, you're maintaining 100 node of cluster, okay? Every day you are data processing terabyte. For any reason, I say you, hey Deepak, do one thing. I'm having some small file, just process the data. What is the file size into MB? Of course, you will use this MB data in this 100 node of cluster, and you give me the output as well. But it's a loss of resource, right? It's a loss of resource, right? And if this kind of job coming frequently, then what will be your option? All right, what will be to travel to 30 kilometer 20-seater, it takes itself a petrol, driver, a van, the cab itself is a big resource, right? You're wasting the resource, so it's better you hire a one auto and get the minimal. That's good. Or get a one bike, a scooty. That's the best way to utilize the resource. So here I'm asking the same question. If you face this kind of situation and if it happens frequently, how you'll maintain the resource? Anyone, any idea how to handle this kind of situation? Just Deepak.
Yeah. So ideally, it will be working as a normal as the web application works. Like we have a resource pool, and initial resource pool size is already been set, and resource pool having the max size also, and as long as the our processing gets the more resources, it will get the resources from that pool. And once the task has been done, it just release that resource. It never assign whole the resource pool for the single unit of task.
Okay, resource put on that. That's clear. But have you heard about Uberization? If I give you Uberization, what the best way? There are too many configuration required, right? There are too many jobs, there are too many configuration need to do. And if it happens frequently, it's a little challenging to maintain the resource pool. Okay, that I understand. But I'm giving you the best solution, specialized for this kind of job. So let me just open me. Yarn anatomy. So that is not my machine, so I'm using this save image. All right. So see here. So guys, this is what I guess you get the more clarity. How the client and how resource manager, node manager, application master, how all it work. This is anatomy. And what you are saying, Deepak, you let me know your way to approach. I'll give it, and let's figure out what the best way to do this kind of job application. So see here, this is the client node. A user send a request. Right. The user send the request given to the client node. Now it send the request to the resource manager. Submit yarn application. Remember I told you who initialized the job? It's the application master. Application master is nothing, it's a Java application, guys. Just understand little in depth. Application master is not a node. Like what is called the node in yarn, we have a two node, only resource manager and node manager. Application master look like yarn components, but actually it is not a yarn components. It's simple application. It's a Java application which helps to initialize any job which is running on yarn platform. Okay, and how it works. See, users send the request, hey, this is what my job, help me to run this job. So let me show you from there itself. Okay, get the pointer. So this is the yarn, guys. I guess my yarn is having the bad health. So I will say, hey, help me to see here. Job history is always down. So I will say, I will just do it automatically, restart this. It will take time. Okay, let me show you. So resource manager. So first is what? Submit yarn application. So client will directly send to the master. Master is what? Resource manager, guys. Now resource manager, your who initialize a job? Application master. Remember that. The job will be initialized by the application master. No resource manager, no node manager. So where this application master is running, resource manager will find out. So in this container, one node where one node manager is running, and on the same node your application master is also. Okay, I'm talking about simple application. So resource manager will send a request, hey, kindly launch this application master because this is responsible to start the job. So resource manager, this is the agenda, launch this application master. So resource manager will send a request to this node manager, and this See here, 2A and 2B. So start the container, and this container node manager is there. And then node manager identifies what launch. So it will launch one application master. So see here, the application master is started and responsible to initialize the job. And from here, all this process will happen. 1, 2A, 2B. Now, this application master will send a request to the resource manager. Hey, allocate the resource. This is all the network topology, guys. This is all this network topology. I believe we have discussed about the network topology as well. This is all the network topology through which the signal connectivity, heartbeat, and all we have discussed before as well. So network, there's a Hadoop network topology itself. The red bus topology you might be heard about, right? Start topology through all this connectivity, signal based, acknowledgement based work is going on. So it's very, very important a network guys to maintain this. So it sent the request, hey, for this job, kindly allocate the resource. So resource manager will allocate the resource. So a resource means what, guys? Remember, we talk about what you mean by the resource container. In this container, all these things come, your RAM, whatever. Container means resource allocate. In 2.x called container, 1.x it's called what? Slot. So it will communicate with the name node. It is actually skipped here. It will communicate with the name node. Hey, the client which user send me the request, user, yes, user data stored on which node. So on which node it will communicate actually what is the, okay, let me give you one more level. This is your data node, right? Let's say user data stored. This issue. Is
So
it okay, guys? Can you hear me? Yeah, can you hear me?
yeah, you are audible now.
Guys, okay, thank you. There was some network issue, guys. So, okay, repeat it again. So coming to this,
So your voice has lost again.
I can't hear you. Just the cursor is moving.
I think he even can't hear our voice.
okay,
Sir, can't hear you. Whatever you said from the top Whatever you have written to when you went to D, writing the D, we cannot hear anything.
I think something is something is problem
Okay.
actually. Suddenly
Hello.
lost your voice.
Okay, just okay. This is a network issue I'm facing. Okay, is it fine, guys? I'm audible.
Yes, now you are audible.
Yes.
Yep. Yeah, is that okay? All
Yeah.
right. You
Yes.
can listen me loud and clear. Okay, thank you. So see here, this
Sir, again we cannot hear you.
Lost you, sir. Something is problem actually.
is what I'm talking about. On every in 2.x, every data, so every data node manager will be running data node having one node. This is
Sir,
also
as
one
you start
point.
explaining, the voice
Is it
is
audible?
lost. No, sir.
Okay.
Only can hear the
You are not
sentence.
facing
Is
this
it?
issue? Okay. Is it fine now? From my end, everything is fine. I'm not what is happening.
Yeah.
Everything is okay, all going good. Let me know if any issue.
Okay.
Is that okay, guys?
Yeah. Yeah.
Yeah.
Hello?
Yes. Yes.
Yes, sir.
All good?
Yes.
Okay, thank you. All right, thank you. Ankita, same issue. Ankita, I'm not sure. From my end, everything is fine. I can see that everything is going good. Please check your
So
mic.
while you
Thank
are
you. So
asking
guys, I'm saying
this,
that on every node man. Yes,
while you are
please.
asking that the voice is fine, that time we can hear you. But while you start writing anything or explaining something, the voice breaks and we cannot hear at all. Just the cursor
Okay.
moves.
Okay. All. Okay. Is it okay now? You can hear me?
Yes.
Yaricha?
Yes.
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 All
Yes.
right. Perfect. All right. Take care. So what I was saying, guys, on data node, on top of data node, a one node manager, only one node manager is running. This is how the cluster is being designed. And you'll get an assignment to design a one cluster with yarn as well, 2.x. So this node manager and one data node, this is a node manager, means it is running on top of one data node. All right, that this point is clear. So it send a request, resource manager, hey, we get a one job, help me to allocate run the application master for this job. So it send the request, hey, node manager, just launch a one application, because this is responsible to run a job. It send a request to node manager, hey, resource manager, allocate me the resource, allocated the resource in terms of container. But in between, what happened, one point is missing here. Resource manager communicate with the name node as well, because this user asked me to run a job, but the user data is stored on which node? Then I will run the job onto that node only, right? So for that, user data stored on which node? Who knows this information? Name node. So resource manager will check with that. Okay, this is the data. Name node will say, oh, this is the. So node manager will actually assign the location where the user's data. So let's say this user data is stored on this data node. So it will assign this node manager, hey, on this user's data is stored onto your node, on your data node. So run this node manager. So location wise, it is mapped, guys. It is not randomly. I'm not running any node manager randomly. The data where is stored, only that node manager will run this. So application process send the request to node manager, start the container, and again this process will keep running. wherever the data, now this is the only the two node manager showing, let's say your data is running on to one, two, we have 100 node cluster, three, your data has been distributed onto 5 data node. So on every node, it will run the node manager. A node manager will be running, node manager will be running, and every node manager, every data node, a node manager will be running. On every node manager will launch what? Application master. Okay, you see here, and then job will start running. Now what is the use of that? A node manager, the job progress, what are the job is happening, this container, how the job is running, this program, so they have to send a report to the resource manager. So resource manager keep monitoring this, all the job, every job is running parallelly. Let's say this job is running 10-minute delay. So if it is a delay, then it will also get delay, no matter it is running on time, because output should come from all the node. That is what distributed application is all about. So for that, resource manager keep monitoring that. We'll discuss more about this, how to monitor and everything. So this point is clear, guys? Yes, please. The flow is clear. User to client, client to resource, resource manager launch, send the request to node manager. Node manager will launch application process, and then this application process will send a request, hey, allocate me the resource, and this is the major application master, and then whatever the user's data is stored on which node, it will launch a node manager onto that, and it will run the job. And this is how the distributed application is running on Hadoop platform. Yes, guys, can I get a quick response? Ankita, Arun, Bindu,
Sir, I have a
Deepak,
question.
Richa.
Hello.
Hmm.
Yep. Am I audible?
Yeah, please go ahead.
Yeah. So in this diagram, sir, 2A
Yes, you're
start
audible,
container
Deepak.
and 2A start container and the 4A start container. Okay. So I believe from this diagram, there are two node managers will be there, right? And each node manager having its own application process, that application master, correct?
Okay, yes.
Yeah. So as you say, like once
Exactly.
the
Right.
once the user sends the request to get the data, resource manager actually find out this data is persist in which data node. Okay, and accordingly the node manager will get
Data.
called,
Right.
correct? But suppose sir, my question is, like, suppose there are the data size is very huge, like the petabytes, right? So in that case, the how does resource
Right.
manager
On which node?
knows?
Yeah.
Yeah, because data is very huge and each data footprint resource manager can't be maintained, right? This kind of data.
Okay.
Hello.
So your question, okay, one thing. Your question is what? How resource manager know the which user's
Yes.
data is stored on which node?
Yes.
Hello.
Yes, sir. Correct. That's the
Yeah,
same
Deepak.
question.
If I'm not wrong, you're saying that how resource manager know which user data is stored on which node, right?
Yes.
I
That's the
mentioned
same
this
question.
part, resource manager contact to the node, name node as well. Yeah, through the name node. Name node maintains the metadata, right?
Mhm. So it contacts to
So
each and
it
every
get,
name node,
let's say user, hmm, each and every name node means
because name node having a
there's only
metadata
one
for the.
active name node, not each and every name node. Right. Okay, let me just help you. So let's say this is one name node and having 5 data node. Fine, Deepak. All right, Deepak. 5 data node we have.
Yes, sir.
Deepak, let's say let's your data. You send me a request. Hey, help me to store this data on this 5 node. Okay. So what is the first phase, guys? Your data will split into blocks. right? So let's say your data gets split into the blocks. How many blocks I got it? 20 blocks. So I put the 4 blocks here. I believe you know this, how the distribution happened, right? 3 blocks here, 10 blocks here, right? And 3 blocks here. Fine, Deepak?
Yep.
Let's say, Deepak, you send a request, hey, run this job on my data. Your data is name is what? F1. So this F1 has been, for me, for you, it's a F1, right? For me, it is 20 blocks, right? Which has been distributed onto this 4 data node. Who maintain this all the location? It's a name node, right, Deepak?
Correct. Correct.
This name node, correct? All right. Chalo. Then you send a request, Deepak send a request. Hey, this is the job I want to know for my developer write a job for Deepak to get some output, right? So Deepak understanding is what? Run this job F1. The file has been total. Okay. So when you do the processing, the responsibility goes to what? Yarn framework. Yep. So Yarn, we send a request to the application client. Hey, Deepak, send me the request. So for this job, the job which Deepak sent, let's say job 1. For this one, first of all, we have to assign the resource, right? So, and you have to initialize as well. First, you have to initialize the job, and then you have to allocate the resource as per the request. Okay. So the first thing is, it send a request, it launched this job, a node manager. All right, this container, it launch a one application master for this job. Okay, so now your job is being initialized. Okay, now for this job, you send a request to the resource manager, allocate me this number of container, this number of resource. This also been done. Now your job J1 should be run on what? On this data, right? So it will give you the output. So this data is stored onto what? One data node 1, data node 2, data node 3, data node 4. So how resource manager know this? Because resource manager does not know anything about the data location. So who know this information? Your name node.
Name node.
So resource manager say, hey, Deepak, send me a job, send me a request to run a job. So I want to know on which of the data node the data has been stored. So I will activate my node manager, because every data node having the resource node manager, right? N1, N1, N2, N3, N4, and N5. So you tell me which node data is stored. I will ask that corresponding node manager to start the job. So it get located, and based on that, it sends the node manager. So now you will start getting a request. This node manager, active this node manager, active this node manager, active this node manager, and active this node manager. You got it? And your job will start now. And how your job will run, this is what running on your machine. Clear?
Yeah. Yes, sir.
Yeah, Deepak?
Yes.
All of you clear? So this is the flow, because your data stored is maintained by SDFS, which maintains the metadata. And now every node manager will start sending the report. We'll learn about this, how to send the report, monitoring, and all that. So till this part is clear, guys. Can I get a quick response from everyone? Ankita, Arun, Bindu, Deepak, Richa. Yes, guys. Waiting for a quick response.
Yes, sir. Got it.
Now, I had one question. I had one question for you. Let's say you have a very small data, right? Let's say, Deepak, you send me a 5 MB data, which is stored on a single node. You got it?
Mm-hmm.
Fine, Deepak? Your
Yeah.
data size is what? 5 MB. Right. Your data size what? What is happening? Just a minute. Okay. Thanks, Richa. Hmm. Okay. So Deepak, you send me the data that is a 5 MB. Okay. And you send me request. Hey, help me to store this 5 MB data, and then we'll process this. So 5 MB data I will store where? On a single machine, right? Is sufficient in a one block, 128 MB your block size. So in a one block your file will come, Deepak. Right.
Yes, sir. Correct. Yeah.
So, right. So when you run the job, right? When you send the job, it send the request, and first of all you have to launch the application master. So you send the application master. So application master is what? It's itself is a Java application, guys. Itself is a Java application. Itself is a what? A Java application. So in this Java application, Java always run what? JVM, right, Deepak?
Yeah.
So now let's say your data is stored onto this. So it will say, hey, for 5 MB data, why should I send a request, allocate the resource, and then again a new container XYZ, right? So it will say reuse the JVM. Which resource to run this job for this particular small file? Reuse the JVM. Do not ask a resource manager to allocate the resource. So it will reuse the JVM. Got it? So it will reuse the JVM of what? Of application master. Clear? It will reuse the JVM of the application master. Clear?
Why is it reusing the JVM just to execute the process?
Right. Right,
Okay. And
because for 5 MB data, I don't think so it required for this. You got it? I given you
okay.
the example of auto, right? Right. So to travel, I believe I given the example, guys. To travel to 30 kilometer for a one cab, 20 seater. If a one person is traveling by one single cab in which you have a 20 seater, it's a waste of resource, right?
Okay. Okay.
I given this example, right?
Yes. So, sir, if the data size is used, so means it in that case it will not use
Let
the
me come. Yeah,
app process the
let
JVM, right?
let me come. Yeah, there's a things how to identify whether the job is small and I should reuse a JVM. I will discuss about that. Let's say you're small, your job can be run easily on a single machine. I should not involve a multiple machine. Got it, Deepak?
Yeah.
How to identify? We'll discuss about. So 5 MB data, I should not send a request, hey, allocate me the resource to run this job. So 5 MB or small file, let's say it's a small job. Let's consider this the small job. So whenever any small job application master will receive, it will reuse its own JVM, its own resource to run this job. It will not do all this process. It will stop by 2B. 2B, it will launch 2B and it will not go for 3 and the other rest part. It will complete this and give you the output. You got it? Okay.
Yeah.
So this is how you utilize the resource. All right. If the job can be done by this single machine, why should it involve to multiple process and a multiple machine? Okay. Got it? You get the benefit, right, of this. Now the question is how to identify which job is small and bigger. So see here, it's good for small job. This is what we talk right now. JVM, reuse the JVM and all. It's technically it is what called Uberized job. Call the Uber job. And Uberization. In Uberization, what say? Reuse the JVM of application master to run the job and give the output. All right. How to identify, how to know that whether the job is small, I should use a single JVM or I should call multiple resource from resource manager. So see that Uber is good for small job. How to find out the job is small or not? If any job having the 10 mapper, one reducer and input size is less than the block size. Find Deepak?
Yeah, yeah.
It will map this parameter. This is the default parameter. All right, you can customize. This is a default parameter. You can customize this parameter as well. So in MapReduce site.xml, you will open the MapReduce site.xml and you will write this property. How many mapper you want to write? Means if you want to customize your small job configuration, for this you will go to the MapReduce.xml and open this, write this property, MapReduce.job.ubertask.max. So it will say 10 mapper. Okay, by default 10 mapper. If you want to make 20, 30, you can do it. For this reducer, if you want to set the property MapReduce dot ubertask MapReduce. So this is what we have. Third, MapReduce dot job ubertask max bytes. So you can set the file size. So this is the property, and this is all the three property. You can go and write it inside the MapRed site.xml. Right, guys? MapRed site.xml. Okay, and you can set this all the property. This property will look like this in XML. I believe you have designed a cluster, and I'm very much sure that you're familiar with this all the MapRed site.xml, core site.xml. So this is all how you can make the changes in the property and do that. Okay, so if any job match with this configuration, it will immediately run this job on a single machine by you reuse the JVM. Okay, it will reuse the JVM and for the small job. But if it not match with this, it will go for further process. After 2 be launched, it will go for 3 and it will go for the 4 and it will involve multiple resource and the node in this cluster. So this is all about Uberization. Any question, guys? So that's all for today's session. Let me know if you have any questions, query. Yes, please. Hello. Yep. Ankita, Arun, Bendu, Deepak, Richa. So assignment for today, you can design a 2-node cluster, 2.x cluster. Okay. In the blog, you can go and check that 2.x. I believe you have already done this. Um,
So do you need to install 2.x again on a Cloudera? That means the zip
no, not
file,
Cloudera.
zip file.
No, yeah,
It's
not
already
in
been there.
Cloudera. Cloudera does not allow. So 2.x. Even Hadoop 3.x is written there. You can design that part. 2.x. This is what you have. So all the process and steps written. All right, guys. Let me send you the link. The softwares are available as well. Okay.
Yep.
Thank you, guys. See you then tomorrow. Tomorrow we'll connect by 11:30. I have some calls. Okay.
Sure. Thanks a lot.
All right. Thank you. Thanks, Richa, Geta, Vendo, Deepak. Thank you. Take care.